Chapter 4 on chemical reactions. So the essence of chemistry, that you're taking something and you're making something new. And we'll learn about the types of reactions and how to identify these reactions and how to predict these reactions. But first is to understand what a chemical reaction is, some definitions, and the basics. So the first thing is a review of physical science. You have physical properties, which basically means that you are observing these characteristics, but the identity of the substance is not changing. So examples: size, you can break it apart, it's physically changing, but the same material substance. So cutting an apple basically is just cutting in, you still have an apple, it still tastes like an apple, so you can have a whole apple, a bite of apple, it's going to be an apple. State of matter, so again, if you are having liquid water and you boil it into a vapor, it's still water vapor. Or you cool it down to an ice, it is solid water. Volume, so for example, if you have a 2-liter soda and you take out 12 ounces, it's still soda. So it doesn't matter about the size. A chemical property changes its substance, so it undergoes a chemical change, and you see this by different characteristics. So burning a piece of paper or burning a candle, burning wood, the wood is something different afterwards. It turns into soot. Explosions, so fireworks, a good example of chemical change. You see that by the change in color. Rotting of an apple or a piece of fruit is changing it. It's not going to taste the same. It's a different composition, and you can't get it back. Rusting, so a piece of iron, it changes from iron Fe to iron oxide, so it's changing chemically by its color change and its appearance. Bubbling, creating a gas. So gas change produces a chemical reaction because that gas cannot be turned back into its previous substance. So you have color change, you have heat, you have a composition change like gas. Any of those will be a chemical reaction. So change is reversible in a physical change. You have a new substance is not formed, so a slice of bread is still bread. Container, volume, size, still Coca-Cola, no matter if it's a bottle or a can. Ice change from liquid to a solid is a physical change. Chemical change are not reversible, so if I take fire, it's going to be into soot or silt, so it cannot be created back into wood. Something rust, I can do a chemical change to get back to it, but I cannot physically put it back into its original state. Same thing with gas, cannot collect it. So quick review: cutting a sandwich, you said physical, it's correct. Burning a match is chemical. Spoiled milk, chemical, because you can't get that back to regular milk. Making popsicles, physical change, you're just changing a liquid into a solid. Rusting of hammer, again, rust is going to be a chemical change, changing color. Emptying a glass of milk, that's physical, you're just putting it into you still have milk. Mixing 2 liquids and turning into a yellow liquid, that is a change in color, so that is going to be a chemical change. And you're making a solid. Making Jello, that is a physical change. We can warm it back up and you still get the liquid back. Okay, all right, so those are a quick review of chemical and physical changes. Now we obviously care about is the chemical reactions. So in chemical reactions, there are 2 types. You have energy that can be exothermic or endothermic. So let's say we have this energy here, this dotted line, 0 joules to 10,000 joules and up to 20,000 joules. Okay, so to get to above the 10,000, you need a thing called activation energy. So kind of think of like being active. You need energy you activate yourself, and that is the energy to start the reaction. So activation energy is the energy needed to start a reaction. So if you're below that number, you need energy up. If you're above that energy or above that energy level, you have energy. Okay. Now, any activation energy can come in the form of light, heat, or electricity. Typically, it's light, but electricity can also be used. For example, if you want to start a fire on your grill, they have a little clicker thing, and that ignites that electricity ignites the propane. So first type of energy is called energenic, and that takes energy from the surroundings. So it needs energy from the surroundings to get back to normal. So typically if something's cold, it brings energy in. So it's endothermic, takes heat from the surroundings. So if something's cold, like an ice cube, and you put it on a piece of table, it's going to take energy from the surroundings, the heat, is going to melt. So think of endo and enter, because it's entering the substance. The second type of reaction releases heat or electricity, and that's called exogenic. Again, it releases energy to surroundings, and in the exothermic reaction, releases that heat to the surroundings. So, for example, a car engine produces energy, and that energy creates heat. That's why the car hood gets hot over time, because it's releasing that heat. Think of exo or exit. So exiting the surroundings, exiting the reaction to the surroundings. All right, so here are some properties. Exothermic releases energy. The temperature is going to increase because that energy is releasing. Some examples are a combustion reaction or oxidation of carbohydrates in our body. That's how we get energy. Even water and calcium oxide is going to create an increase in temperature. Endothermic are absorbing energy from the surroundings. The temperature is going to decrease, okay, in a reaction. Decomposition reactions are typical because it has to take energy in the surroundings to decompose. Photosynthesis, even adding a simple substance to water can cause a change in temperature to drop. These are your basically, if you have like pouches of ice packs that are crunchable and then it releases, makes it cold, that's an endothermic reaction. So fire producing is exothermic. An endothermic reaction would cause temperature to go down. The decomposition of something, you're heating something up, is going to be an endothermic reaction because it needs heat to absorb. And a photosynthesis is absorbing the heat from the sunlight from the earth, from the sun, and it's going to produce oxygen. All right, so on page 2 of your notes, you are going to identify parts of a chemical equation. So do that. You have a word bank, and you're going to fill in each of those from the words. So do as many as you can. You pause the video, and then we'll go over the answers. All right, so these are your answers. Make sure we check it. You may not know all of them, but you should know some. So A is reactants. So you start with the reactants in a chemical reaction. B is your products. You're producing something, which makes sense. The AQ stands for aqueous. So the AQ with NiCl, nickel 2 chloride, is aqueous, which means it is in solution with water. L is for liquid. Obviously, water is a liquid. So the difference between aqueous and liquid is that an aqueous is a solution with something. Salt water is a solution, where liquid water is pure, nothing combined with it. The 2 after nickel hydroxide, the 2 is the subscript. So we talked about that with chemical formulas. S is solid, so for F, it should be pointing to the S. Sorry about that, kind of messed up. The coefficient is the number 2 in front of NaCl. So a coefficient, just like in algebra, is the number in front of something. And the arrow is yields or produces. So yield is the more common term. So reactants yields to products. It's kind of funny to say reactants produces products. So yield is the arrow. All right, again, quick introduction or maybe a review of what these symbols represent. So you have L for number 1, AQ for number 2, S for 3, and 4 is G. So you should be able to identify which one's which. L is liquid, so you should have B. D is AQ, dissolved in water, aqueous. S is for solid, and G is for gas. All right. There's different ways to generate activation energy: heat, light, and electricity. So when you have heat above the arrow, you're going to have reactants that are heated, obviously. Reactants exposed to light would be light. And ELEC stands for electricity or current that you put in front of the top of the arrow. So if something's being heated, you would put heat on top of the arrow, the yield sign. If something's exposed to light, you put light above the yield sign. If something is exposed to current, you put ELEC for electricity above the yield sign. All right, so this is where we get into identifying things about reactants and products. Okay, so this goes pretty easy, identifying the reactants of the chemical equation and identifying the products. So you should go pretty quick. You should see the left side of the reaction are the reactants, N2 and H2, and the right side is your products, which is NH3. H2O decomposes into H2 plus O2. The reactant, yes, water. Products, H2O2. Done. All right, this is a little longer, but NaCl with HCl, I'm sorry, Na with HCl makes NaCl and hydrogen gas. So reactants, Na and HCl, products, NaCl and H2. So you can continue on. We have a combustion reaction that is a hydrocarbon, C10H8, combusts with oxygen. You're going to have those as your reactants. Your products in every combustion reaction with a hydrocarbon produces CO2 and water. All right, keep going along. CH2 and S are and F2 are your reactants. Products, you have 3 products here: CF4, H4, and SF6. Or HF, sorry. HF, SF6. Here is production of water. So this is also a combustion reaction because it's defined as reaction with oxygen, but also a synthesis reaction that you're making a product out of their elements. H2O2, and product is water. Easy peasy. All right, counting atoms. Now, again, this is all about the subscript. Knowing how many atoms you have is important because we have to make sure we have a balanced reaction. So on page 4, you are going to identify how many reactants you have. So this example of N2H2 yielding NH3, you have a subscript, indicates how many atoms of that element. So for nitrogen, you have 2 nitrogen atoms. For hydrogen, you have 2 hydrogen atoms. For nitrogen, you have 1 nitrogen because there's no number there. It's going to be a 1. And then for hydrogen, it is 3 hydrogens. Okay. Here is another example. Here you have 2 hydrogens, 1 oxygen. If you said 2 hydrogens, you're correct. And for oxygen, there's 2 oxygens. Again, pretty simple, just count. So you have some examples to do. NaCl, you should see, or sorry, Na, you should see that you have 1, hydrogen 1, chlorine 1. All right, product side. 1, 2 hydrogens, because H2, and chlorine is 1. All right, C10H8O2, so carbon, 10, hydrogen, 8, oxygen, 2. Product side, you have 1 carbon, 2 hydrogens, 3 oxygens. Be careful there because CO2 has 2, hydrogen has 1, 2 plus 1 is 3. All right, number 3 example, carbon is 1, H is 2, sulfur is 1, fluorine is 2. Here, carbon on the product side is 1, hydrogen is 1, sulfur is 1, and then how many F's? If you said 11, you are correct. 4 from the first one, 1 from the second one, and 6 from the third one. So you gotta add them all up. All right, so these two you need to do on your own. Will get checked in class. So how many reactants you have of each atom and how many products of each element you have for number 4 and 5. That's on page 5 of your notes. And do number 6 of C3H6O reacting with oxygen. Be careful with oxygen on both sides. All right, now we move on to what happens when you have coefficients. All right, so more math. Now we know how many atoms we have. We have to multiply by a certain number of coefficients based on balancing the reaction. We'll get to balancing later. But the coefficient just tells me that I have 3 molecules or whatever substance I have of hydrogen, H2. So it is a coefficient times the subscript. So it'll be 3 times 2. So nitrogen has no subscripts, 1 actually, not 0, 1. So it's 2 nitrogens. Here you have 3 molecules of H2. So it's H2, H2, H2. That's 6 hydrogens. Here you have 1 nitrogen in NH3. There's 2 of them. There's 2 molecules of NH3. That means there's 2 nitrogens. And for hydrogen, you get 6 hydrogens. Okay, so absorb that a little bit. Make sure you understand how we got those numbers 2 and 6 for nitrogen and hydrogen. Again, it is basically saying that we have for H2, we have 3 molecules of H2, and each one is worth 2, so it's multiplying 2 times 3. So it's basically multiplication. Here we have H2O making H2 and O2. So you have coefficient of 2. So for hydrogen, you should get 4. Okay. Oxygen, you have 2. Because oxygen is 1 subscript. 1 times 2 is 2. For hydrogen, again, you should have 4. 2 times 2. And for oxygen, 2 oxygen atoms. Okay. Here, C10H8, 10 carbons. Hydrogen is 8. Oxygen, 24, because 12 times 2. And on this side, we have 10 carbons. We have 20 oxygens plus 4 more oxygens of 24 oxygens. So again, when you have oxygen on both sides or on multiple compounds, you have to make sure you add them together. And for hydrogen, it's 8. Okay, so that's number 2 of your example. I'm not sure why we did that one. So example 1 or problem 1, you have a 2 in front of Na, so you have 2 sodiums. You have a 2 in front of HCl, so it's 1 times 2 is 2, and 1 times 2 is 2. So you should have 2, 2, and 2 for Na, H, and Cl. And on the product side, you should have 2 hydrogens, and you should have 2 chlorines. These should equal together because they are balanced reactions. We did this one in that last slide, so we should have 10, 8, and 24. And again, 10, 8, and 24. Again, remember how to get 24 is there's 10 carbon dioxides, that's 10 times 2. And then there's 4 waters, which is 4 times 1. So 20 plus 4 is 24. All right, number 3. Let's see what you guys get. You get 1 carbon, 2 hydrogens, 1 sulfur, and 12 fluorines. And if it's balanced, it should be the same. You have 1 carbon, 2 hydrogens, 1 sulfur, and for fluorine, we have 4 plus 2 plus 6, so that is 12. There you go. Production of water, you should have 4 hydrogens, 2 times 2. 1 times 2 is 2 for oxygen. Hydrogen, again, 4, 2 times 2, and then oxygen is 2 times 1. So these 2 examples you need to do on your page 7 of the notes. Again, that will be checked in class. All right. So we must balance the chemical equation if it does not meet this law. How do we do this? They call this magic, but it's really just simple math, and we'll get to that soon. So coefficients are what used in front of these compounds or atoms, and that will help us balance the number of atoms on both sides of the reactions and products. So we have to place it before the formula or the compound symbol, just like in math, any number in front, and we use that to balance the atoms. So you can see here, 1 methane, CH4, and 2 oxygens are coefficients, 1 CO2, and 2 hydrogen or 2 waters are coefficients for water. Okay. So how many oxygen molecules in the reactants do we have? So molecules is how many O2s we have, and you have 2 of them. How many CH4 molecules do you have? You have 1. How many CO2? 1. How many molecules of water? 2. So those are the numbers in front, those coefficients, what they mean. So 2, 1, 1, and 2. So we are on no page. Okay. So this is going to be part of your homework question to answer these type of questions. Now, we use the coefficients to tell you how many atoms there are. So there's a difference between number of molecules and number of atoms. So for the coefficient, this is where you have to multiply by the number of atoms you have in that one molecule. So for carbon, so 1 times 1 is 1. For oxygen, it's 1 times, for hydrogen, it's 1 times 4, because there's 4 in front of, after the H in CH4. Oxygen atoms in the reactant, 2 times 2 is 4. Carbon in the products, 1 times 1 is 1. Hydrogen, 2 times 2 is 4. And for oxygen, again, there's 2 places oxygen has, 1 in CO2 and 2 in waters. So you should get 1 times 2, and that comes from the CO2. And then the 2 times 1 comes from the water, and that gives you a total of 4. So you gotta make sure you add them up. Everything's balanced. So that's how you should tell if the reaction is balanced, is that you have the same number of both the reactants and products of that atom. All right, here's another example. We have how many zinc molecules or atoms, and you should how many molecules of HCl, how many molecules of H2, and how many molecules of ZnCl2. So those are your coefficient numbers. So you should have 1, 2, 1, and 1. Now to determine the number of atoms, we have to multiply that coefficient by the number of atoms you have in that molecule. So for zinc, it's 1 times 1. For hydrogen, it's 2 times 1, because the coefficient is 2, and there's 1 atom of H in HCl. Same number for chlorine. Zinc on the product side, again, 1 by 1. Hydrogen should be 1 times 2, because there's 2 atoms and 1 molecule of hydrogen. And chlorine should, again, 1 times 2. Looking at all these numbers, if they are the same on both sides. Zinc is 1 and 1. Hydrogen is 1 or 2 and 2, and then chlorine is 2 and 2. So they are balanced reactions. All right, same example. Let's look at nickel chloride. You should have 1, 2 for NaOH, 1 for NiOH2, and 2 for NaCl. Again, those are the coefficients in front of the compounds. Atoms, you get 1 for nickel, 2 for chlorine, 2 for sodium, 2 for oxygen, and 2 for hydrogen. Okay, so the reason why Na and OH are always 2 because there's 2 molecules of NaOH. So it's like NaOH plus another NaOH. So 2 atoms of Na, 2 atoms of oxygen, 2 atoms of hydrogen. On the product side, nickel is 1 and 1. And for chlorine, 2 times 1, because there's 2 in front of NaCl. For sodium, again, 2 times 1, because there's 2 in front of NaCl. Now this gets tricky. There's parentheses with OH. So it means there's 2 groups of OH2. So there's 2 atoms of oxygen there. And there's 2 atoms of hydrogen there. Okay, it's like distributed property in math. They're all balanced, so we know the reaction is complete. All right, here we have CH3, 1 number in front of the coefficient, so it's 1 molecule of CH3, 5 of O2, that should be CO2, 3 in front of CO2, sorry about that, and 4 in front of H2O. So how many atoms of carbon are there? 3 for carbon. How many for hydrogen? 8. Oxygen, 10, because there's 5 groups of O2. So it's like 5 groups of 2, which means 5 times 2. Carbon should be 3. Hydrogen is 8. And then oxygen, you have 2 places for oxygen. 3 times 2, sorry. And that's 6. And 4 times 1 is 4. That gives you 10 of oxygen. All right, so these are your 2 problems for homework. You have to identify the coefficients. So what are the coefficients for this equation? Identify the number of molecules of H2O, number of molecules of hydrogen, number of molecules of O2, and then the atoms of H on the reactant side and oxygen on the reactant side, and the number of H and O on the product side. So that's the first problem. So you can do this on a separate sheet of paper, and then you upload it to Teams. The second question is the cadmium nitrate with hydrogen sulfides, a little longer because there's 5 different elements here. And you gotta identify the coefficients for each one. So what's the coefficient for each molecule, and then how many molecules for each one, and then how many cadmium atoms on the reactant and product side, how many nitrogen atoms on the reactant and product side, how many oxygen atoms on the reactant and product side, how many hydrogen atoms on the reactant and product side, and how many sulfur atoms on the reactant and product side. All right, so we will check your answers. Make sure you turn in your homework on Teams, and they're done.